Okay, here is the example. There are two functions f1 and f2. f1 here is sine of 2x and f2 here is sine of x into cos of x. Basically f1 means f1 of x and f2 means f2 of x. So first of all, what we do, we just write the linear combination of it, and linear combination is c1 into f1 of x plus c2 into f2 of x must be equal to 0. This combination must be equal to 0. So I am replacing f1 c1 into f1 is sine of 2x plus c2 f2 is sine of x into cos of x equals to 0. So the basic identities and formulas we have to use in this type of things. So you know that since sine of 2x is equal to 2 into sine x cos x, so I can replace here c1 into 2 sine x cos x plus c2 sine x cos x equals to 0. So it becomes 2c1 sine x cos x plus c2 sine x cos x equals to 0. Now I told you that you have to guess the combination. You have to guess the values of c1, c2. That makes this combination equals to 0. So what values, per particular or arbitrary values of c1 and c2 you have to guess, which makes this combination equals to exactly equals to 0. Think about it and tell me. If I take c1 as 1, because it is a 2c1, so 2c1, c1 is 1 and c2 is, let it be minus 2, yes, then this combination can be equal to 0. Okay, my guess was right. c1, let it take 1 and c2 is what I thought, yes, I guess it is minus 2. Then 2 sine x cos x plus minus 2 sine x cos x, that makes it 0. So c1, c2, these are the values. You can also take other values, it is not a unique value. So if I take c1 as 1 by 2 to make it 1 and c2 is minus 1, so that also makes it 0. And I can also take it as c1 as minus 1 by 2 and c2 equals to 1. That also makes the combination 0. So there are several values that makes this combination equals to 0. So in every type of selection of these particular values of c1, c2, you can see that all these two c's, here there are two c's, so these c's are non-zero. So that makes it, you have to check that whether these functions f1, f2 makes a linear combination linearly independent or no, or dependent. So you can definitely see with every selection of c, the c's are completely not 0. So that means that these functions are what? Linearly check it, check the combination. For independence you have to select all the c's are 0, it must be 0, but here it is not, so that means it is not independent, that is dependent. So functions are linearly dependent. Okay, next example number 2. Example number 2 has 4 functions, and you have to check that whether these f1 of x, f2 of x, f3 of x, f4 of x are linearly dependent or independent. So first of all, write the combination. Combination is c1 f1 of x plus c2 f2 of x plus c3 f3 of x plus c4 4 of x. This combination must be equal to 0. Replace f1 cos 4x plus c2 sin square x plus c3 secant square x plus c4 tangent square x equals to 0. Okay, select what you have to select the values of c1, c2, c3, c4 to make this combination equals to 0. So in the first two terms, in these two terms, I can use the identity. That identity was sine square plus cos square equals to 1. So here I am writing the identity, sine square plus cos square equals to 1, and in this c3 c4 I can use the identity secant square x equals to 1 plus tangent square x or tangent square x plus 1, or secant square x minus tangent square x equals to 1. So I have to do something with these two properties, these two identities, to make this combination equals to 0. So if I replace c1 c2 as 1, then this combination becomes 1. Cos square plus sine square equals to 1, and I have to make sine square minus secant square secant square with these last two terms, third and fourth. I have to make it secant square x minus tangent square x. So what should I do? Tell me. C1, if I select C1 as 1, and if I select C2 as 1, then cos square plus sine square equals to plus 1. And to make it minus 1, I can use this identity. I can also use this identity as tangent square x minus secant square x equals to minus 1. It is it can be any value. To make this combination equals to 0, I can play with it, I can use any technique. Okay, so tangent square x minus secant square x. So if I take tangent square, along with the tangent square I take c4 as plus 1, and secant square, if I take it c3 as minus 1, then I have to check whether this combination makes it 0 or not. Cos square x plus sine square x, c2 is 1, minus secant square x plus tangent square x equals to 0. So this is 1 and this is minus 1. Yeah, it is 0. Yes, this combination is good. Okay, you can also do any other combination or any other thing. So with this combination, it is only at least one. So these c's are all non-zero. So these functions are definitely linearly what? Dependent, because all c should be equal to 0 for linearly independent. So these are linearly dependent functions. Okay, next example. 4 functions, 4 combinations. So writing this combination, c1 f1 of x is under root x plus 5, guess hit and trial method, plus c2 under root x plus 5x plus C3 F3 is x minus 1 plus C4 into x square equals to 0. So this combination, how and what values, particular values of C1, C2, C3 and C4 makes this combination equals to 0? Think about it and let me know. If I want to cancel this C1x, and if I make it minus under root x, then these two are cancelled. Okay, and if this is a constant, minus 1 is also a constant. If I make it minus 5, then 5 and minus 5 can be cancelled. Okay, 5x. So if I multiply this with 5, and 5x should be with a specific value can be cancelled. And what else? X square. C4, I select C4 as 0 because it cannot be cancelled with any other vector. So think about it. C1, C2 basically are constants here, not specific functions. Let me select this. If I take C1 as 1, C2 I have to cancel it with under root x and under root x. So if I take C2 as minus 1, this becomes minus 5x due to that. Minus x minus 5x. So already it becomes minus 5x, and if I multiply this with minus 5x plus 5x, yes. If I take C3 as 5, so minus 5x plus 5x, yes, it gets cancelled. Minus 5, so plus 5 minus 5 gets cancelled, and C4 is selected as 0. Yes, this combination is good. Plus x, this, minus under root x, minus 5x, right? C3 now here is 5, so it becomes 5x minus 5 multiplied both sides plus 0 into x square, plus x minus plus under root x minus under root x plus 5 minus 5 minus 5x plus 5. Yay! This combination is equal to 0. So my guess was right. But one thing, I still don't get all the C equal to 0. So it is not linearly independent. These functions are linearly dependent functions. So that means with these examples that if I have such type of values that do not depend on each other, a unique combinations, a unique functions that cannot be cancelled with other functions, like f1 is unique with the rest of the functions, f3 is unique with rest of the functions, f3, f4, any function can be are unique, then I have to take all c equals to 0 to make it a linear combination equals to 0. So that is linearly independent, otherwise it is not. This combination is linearly independent functions. I hope that you understand these linearly dependent and independent functions. In the next video I will tell you the other method, and that is very authentic method to check that whether the combination is linearly independent or not.